Good day, sir. I am Mary Rose Rivas, your reporter for today. Okay, I have here a short video clip, and I want you to observe what have you seen from the video. Later on, I will ask you some questions about the video. Okay, what are your observations from the video clip that I showed to you earlier? So, the video clip that I showed to you earlier is one of the sheet metal machine tools, which the people are the one operating it to make work much easier. And that machine is used for cutting sheet metal. So what do you think is our lesson for today? Our lesson for today is all about cutting operations in sheet metal. But before we proceed to our proper lesson, may I read to you our objectives for today. So at the end of this lesson, you will be able to first explain how cutting operations in sheet metal being processed and used. Second, identify the different types of cutting operation. Third, analyze how the process parameters and cutting forces in sheet metal can be determined. And fourth is to understand how the cutting operation in sheet metal being done through watching short video animation and video application. Okay, why do you think cutting operations are very important? Cutting operations are very important part of sheet metal working because cutting is used to separate large sheets into smaller pieces, to cut out a part perimeter, to make holes in a part, and the tooling used to perform cutting operation is called a punch and a die. So, we have here the types of cutting operation. So, the following are the types of cutting operations performed in sheet metal working. So, we have here shearing, blanking, punching, cutoff, parting, slotting, perforating, notching, trimming, shaving, and fine blanking. So let's go to shearing. It is a sheet metal cutting operation along a straight line between two cutting edges. It is typically used to cut large sheets into smaller sections for subsequent press working operations. It is performed on a machine called a power shear or squaring shear. Shearing operation. So the figure is shown today is a shearing operation. We have here the figure A, side view of the shearing operation, B, front view of the power shears equipped with inclined upper cutting blade, and the symbol V there in the upper part of the figure, it indicates motion. So, the cutting of sheet metal is accomplished by shearing action between two sharp cutting edges. The shearing action can be divided into 4 steps shown in figures. So, this is the figure. Okay. So, the shearing action is depicted in the 4-step action that is being shown in the figure, in which the upper cutting edges sweep down past a stationary lower cutting edge. So as the punch begins to push into the work, plastic deformation occurs in the surfaces of the sheet. As the punch moves downward, penetration occurs in which the punch compresses the sheet and cuts into the metal. This penetration zone is generally about one-third the thickness of the sheet. As the punch continues to travel into the work, fracture is initiated in the work at the two cutting edges. So this is the feature of sheared edge of work. So the sheared edges of the sheet have characteristic features as seen in the figure a while ago. So at the top of the cut surface is a region called the rollover. This corresponds to the depression made the punch in the work prior to cutting. It is where initial plastic deformation occurred in the work. So just below in the rollover is a relatively smooth region called the burnish. So this results from penetration of the punch into the work before fracture begins. Beneath the burnish is the fracture zone, a relatively rough surface of the cut edge where continued downward movement of the punch caused the fracture of the metal. So finally, at the bottom of the edge is a burr, a sharp corner on the edge caused by elongation of the metal during final separation of the two pieces. So this is the characteristics of sheared edges of work. We have the rollover, the burnish, the fractured zone, and the burr. So now let's go to blanking. Blanking, it involves cutting up sheet metal along a single step to separate the piece from the surrounding stuff. So the part that is cut out in the desired product in the operation and is called the blank. So as 16 figure, blank is called the desired product in the blanking operation. Punching. Punching is similar to blanking, except that the piece that is cut out is called the slug. So the remaining stock is the desired product. So another information to put in, blanking and punching are similar sheet metal cutting operation that involve cutting the sheet metal along a closed outline. If the part that is cut out is the desired product, the operation is called blanking and its product is called blank. If the remaining stock is desired product, the operation is called punching. So let's go to cutoff. Cutoff is a shearing operation in which blanks are separated from a sheet metal strip by cutting the opposite sides of the part in sequence, as shown in figure. So with each cut, a new part is produced. The feature of a cutoff operation that distinguishes from a conventional shearing operation: one is the cut edges are necessarily straight, and two, the blanks can be nested on the strip in such a way that scrap is avoided. Parting. Parting involves a sheet metal strip by a punch with two cutting edges that match the opposite sides of the blank, as shown in figure. So this might be required because the part outline has an irregular shape that precludes perfect nesting of the blanks on the strip. Parting is less efficient than cut-off in the sense that it results in some wasted materials. We have here slothing. Slothing is a punching operation that cuts out an elongated or rectangular roll. So as you can see in the figure, it is being cut out by making a rectangular hole. Perforating. Perforating involves the simultaneous punching of a pattern of holes in a sheet metal. So the hole pattern is usually for decorated purposes to alloy of passage like gas or fluid. Notching. Notching involves cutting out portion of a metal from the side of the sheet or strip. Semi-notching removes the portion of a metal from the interior of the sheet. So, as you can see in the figure shown, the notching, semi-notching removes a portion of the metal from the interior of the sheet. So we have here trimming. Trimming is a cutting operation performed on a form part to remove excess metal and establish size. A typical example in sheet metal working is trimming the upper portion of a deep-thrown cup to leave the desired dimensions of the cup. Shaving. Shaving is a shearing operation performed with very small clearance to obtain accurate dimensions and cut edges that are smooth and straight. So as picture in figure shown, so shaving is typically performed as a secondary or finishing operation on parts that have been previously cut. Then lastly, we have here the fine blanking. It is a shearing operation used to blank sheet metal parts with close tolerances and smooth straight edges in one step. So this process is usually reserved for relatively small stock thickness. Okay, we have here analysis of sheet metal cutting. So, the process parameters in sheet metal are: 1 is the clearance between punch and die, 2 stock thickness, 3 type of metal and its strength, and 4 is the length of the cut. So let's move on clearance. So the clearance C in a shearing operation is the distance between the punch and the die. As shown in figure, typical clearances in conventional press working range between 4% and 8% of the sheet metal thickness, T. So that is representing by T. So the correct clearances depends on sheet metal type and thickness. So the recommended clearance can be calculated by the following formula. So we have here C is the clearance, AC is the clearance allowance, and T is the stock thickness. So the clearance allowance is determined according to type of metal. So the effect of improper clearances is illustrated as what you've seen in the figure. So the clearance in a shearing operation is the distance between the punch and the die as shown in figure. So we have here, if the clearance is too small, then the fracture line tends to pass each other, causing a double burnishing and larger cutting forces. If the clearance is too large, the metal becomes pinched between the cutting edges and an excessive burr results. So in special operation requiring very straight edges, such as shaving and fine blanking, clearance only about 1% of stock thickness. Then we have here the cutting forces. So estimates of cutting forces are important because this force determines the size or the tonnage of the press needed. So cutting force F in sheet metal working can be determined by F is equal to S T L, where S is the shear of the sheet metal, where T is the stock thickness, where L is the length of the cut edges. Okay, I have here a short video animation, one of the types of cutting operation in sheet metal. I want you to observe and watch it thoroughly. Okay, that is an example of cutting operation. So I have here also another video or a last video that I will be going to show you. And this is the actual operation in sheet metal. So have your own observation from the video because later on you will have the knowledge on how the actual operation is being done. that is all about from the actual operation of sheet metal, how the process of cutting operation important, and how technologies are being used to cut um, or being used from that operation. And I hope you learned something from the video, and I hope it will give you some knowledge for your future references someday. Okay, that is all for my report today. So, thank you for listening. I hope you learned something today. Thank you, take care, and God bless you all.